Hey, so Monday we did our lab. Yesterday we had a quick video. I know 10 minutes doesn't seem quick, but just imagine how long I would have rambled if I was in class. Talking about how you did the calculations. This last big idea that we're doing is still just stoichiometry. You take the amount of one reactant and boom, 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 train tracks how much product can you make, but you also do it with the other one. So it's not harder, it's just twice as much stuff. Then once we are done, we have two answers. The smaller one is the right answer. That's what we're practicing today. That's what we're practicing tomorrow. That's what we're getting ready for our quiz. So, really, what we're doing with this is reviewing and practicing all of our stoichiometry skills again. And remember, stoichiometry uses molar mass, molar volume, Avogadro's number, molarity, and the ideal gas law, all the stuff that we've done all trimester. So we are reviewing for the final as we do this. So first, we've got some definitions. We've got two things here that we talked about yesterday. We talk about our reactants in terms of being the limiting or the excess. Hopefully, we kind of know what those terms mean and they make sense from yesterday, but they are all about what we have a little bit of and what we have, quote, too much of or left over of. So right here, we can see the limiting runs out first. It tells you how much product can be made. When we do all of our calculations and get two answers, the thing that gave us the smaller answer was the limiting reactant, and the smaller answer is called the theoretical yield. We do all of our math, and the one that gives us our larger one is the one that we have too much of. It is the excess. It's not totally used up. But when we do this, it's do the math for both things all the way to the end. So here, number one, and I can go through any or all of these with you, but really it's just understanding we're doing choo-choo tracks or stoichiometry all the way to the end. Consider this reaction. We've got it balanced. If it just gave us the amount of calcium sulfate, we would know exactly what to do. If it just gave us the amount of sodium iodide, we would know exactly what to do. We're just doing both of those things that we know exactly what to do. Grams to moles, moles to moles, moles to grams. Every single problem, we change the amount that they give us from whatever it is to moles. We use our mole ratio to get from the chemical we know about to the chemical we're trying to find out about. And then, sorry, we do our calculation to get what we're trying to find. This time we're trying to find out about grams of sodium sulfate. So when I did this, grams to moles, moles to moles, moles to grams, grams to moles, moles to moles, moles to grams. Molar mass, mole ratio, molar mass. You have to show all of that. We are still using NUF, number unit formula, in each step. So we are thinking about how much could we make. We can know what the limiting reactant is because it's the thing that ran out first or the thing that can make less. So it's not this number, it's the chemical that gave us this number, the sodium iodide. So that's why it says that. How much product can actually be made? We did all of this, we can make this. It doesn't matter if we have 10 packages of bread. If we have a certain amount of slices of cheese, that's how many grilled cheeses we can make. So that's what's going on right here. So when we do two sets of train tracks, we answer both of those questions using now our limiting reactant, how much excess is actually used. So our sodium iodide is what ran out. It made a certain amount of sodium sulfate. We could not use all of our calcium sulfate. So this is where it gets a little bit longer. We're not going to ask you to do all of these parts on every one, but we take our amount of product that we actually got. So we have our theoretical yield there, sorry. And we think, we're going back to see how much of that calcium sulfate did I actually use. If I had 4 pieces of cheese, how many slices of bread did I actually use? So I take the amount that from my limiting reactant, work backwards and get that. The last question is how much is not used. In other words, how much is left over? It is the amount we started with minus the amount that we used for the amount that's left over. We're always going to follow this same format, but the idea, all stoichiometry, are starting amount to moles, moles to moles, moles to amount, but do that for both reactants. The one that gave us the smaller amount was limiting. The smaller amount itself is the amount of product that's made. And then sometimes we try to figure out how much stuff we used. So we filled in our tables here. We did all of that math together. Here, you need to think about, what do we need to do? I have the amount of one chemical and the amount of the other chemical. So we have two sets of tracks to do. If all of the magnesium reacts, how much stuff do I get? If all of the oxygen reacts, how much stuff do I get? Then I look, what answer is bigger or smaller? The smaller answer is the amount of magnesium oxide I actually get. The chemical that gave me the smaller answer was limiting. The chemical that gave me the larger answer was excess. What's a little bit different here is that we're starting in moles. We don't have to change to moles, so we start our tracks with moles. So we'll look at that right here. Moles to moles, moles to grams, answer. Moles to moles, moles to grams, answer. That is the right answer. So we can even take that guy. When we get two answers, we would bold, or if we were asked how much is actually made, that would go in our answer box. Here, number 2, aluminum and copper 2 sulfate. How much copper is made? Grams, moles, moles to moles, moles to grams. Grams, moles, moles, grams for both. We get two answers again. Same idea. Grams, moles, moles, grams, grams, moles, moles, grams. The smaller of the two is, I'll stretch that out, the answer. Here, it breaks it down into all of the pieces. Check out the answers, but it's all about, we have to do two calculations. We have to then know the smaller answer is the answer. Here, it also adds in some percent yield. Once we know what's going on, we can still do actual over theoretical, and we can think, like we did at the end, well, if I know how much I made, how much did I use, and how much is left over? So we've got our answers for that here. But every one, we're setting up our tracks, we're getting two answers. An important thing to note is it's not, here we have an equal amount of each, so it's not the thing that I have less of necessarily. It's the thing that makes less. If I had 4 slices of bread and 4 pieces of cheese, the bread would run out first, even though I have an equal amount of each. 6 slices of bread even and 4 slices of cheese, the bread would still run out first, even though there's more of it, because we have to account for the recipe, which the recipe for us means the molar mass, it means the mole ratio for those. So that's why we do the full set of work for both. On this, we did those examples. We really just want to spend a lot of time doing that. If you haven't finished up the Balloon Lab Canvas assignment, work on that. Ask questions of me. There's also a short problem here, or excuse me, a short assignment. We're not trying to kill you with lots and lots of repetition, because you do have to do multiples on these. If you need help on either of those, there's a short video embedded in each to help you out.